Welcome back, guys. So today, let's just start with where we left off yesterday. So I remember going through the different ASPs for different ELs, and particularly the alias, that is the ASP, which will be pointing to ASP EL0 and whichever exception level we are currently in. So yeah, that was something new that we learned yesterday. And so the context should be that I was trying to switch from my kernel to my user process, and as soon as I switch, I got an exception. I'm trying to access an address that is supposed to be only accessed from the kernel. That's the address range that starts with 0FFFFF. And I was trying to see what are the things that are currently saved and restored, and because whenever we are switching into something, we need to replace all the registers back. And one of the thing that we wanted to make sure was the table, and turns out the table value was correct, and we did fix something in the context, the ordering of the things. So how we save and how we restore and how we actually interpret my struct. There's this context, this struct. So this will be placed in the stack. So to read the different fields, I need to know from which byte that particular value can be read. And we fixed this yesterday, and right now we are able to access things properly, so that's fine. What else is left? Other than that, the next thing I wanted to confirm was that whether I was saving my stack pointer at all, because when I get into my user process, the first user stack is pointing to something that is not meant to be in from user level. So I was checking if my mapping was correct, whether I have properly fixed the stack pointer values, and then I checked if maybe I'm not even saving my stack pointer at all. That's when I realized that I am saving the stack pointer, but then I was saving something like SPEL1. No, SPEL0. Where is it? I think we can show it here too, because if we go to restore and return, as you can see, we are taking some field within my context struct and placing that into SPEL1. So we are updating SPEL1, and this will be directly aliased from EL0. Whenever we are in EL0 and we just try to access this SP, we should automatically be able to get to this SPEL0. But that's what I was assuming, but turns out this p state SPL select should be 0, and only then we'll be accessing this. And if the p state is 1, it will select based on the EL level, and those will only be EL1, 2 and 3, not EL0. And in these levels, if we want to access SPL0, we need to use the MSR. Okay, What about if we have p state select equal to 1 and we are inside EL0, what happens? Maybe okay, this is what we need to confirm today and then fix the entire thing. Can we use ESP EL0 and ESP? What's that? Set 1. No, cannot use if I'm inside EL0 and is set to 1. I mean, okay, so as soon as we switch, it will automatically be set to 0. Okay, then we don't even have to get into this point. So as soon as we get into EL0, we should definitely have the value set, but this it's not specified specifically anywhere, but I think that's how it works. So in that case, I am writing my whatever struct value I take from here into my SPL0. So if I jump after this, my stack pointer is supposed to be pointing to something that I wrote here, right? Let's run it. We have to break anywhere. I think so. I have to break maybe around first. Do we have any old breaks? What is this? Okay, let's stop there. Okay, it did not stop there. Maybe today it got placed somewhere else. Disassemble first user enter. Okay, maybe let's stop here. What? I did not even reach that. What happened then? Okay, that's not good. So it should be in Camo. Okay, what do I find inside that? What do I find inside that? Grab, let's say, I need every far, and I need 5 of them, and I need the head. Okay, it's still the same error. We try to access something. First of all, I need to figure out what the fuck is that FFFFF. I think it's my note. Wait. Let's just confirm one more thing. No, my user stack is supposed to be either this or this. And if you come here and put that here, it's the same value. It should be supposed to be something like this. Maybe. Wait. If we go into my main and if we check, which one am I printing? I am printing use stack that is coming from the kernel to user space. So that should be fine. And I have mapped ID to user stack. Okay, I get it. What am I doing is here is that through here I am inside EL0, EL1, and I have a current table that has identity mapping are tables for 0x FFFF something to 0x000 something, and my kmalloc gives me 0x FFFF something as the address. Now I am trying to convert that into my user space by zeroing the upper bits. So let's say I get 0x000 something, and then I am trying to map this. What is 0x000 something to what? This is the address. What will I map it into? I think I am going to map it into address. So that is correct, because that just means I'm creating a mapped entry into 0x000 something. This something is the actual physical thing, because even from my EL1, this 0xFFF is pointing to 0x something, and it's identity mapping, so whatever that was here will be the same here too. Or is it? No. Yeah. Okay. Kmalloc starts from 0xc. Okay. That makes sense, because my Kmalloc is not identity mapped. It's something plus 1 GB, I believe. Because my Kmalloc's base address is... where's my base address for Kmalloc? Yep, my base address is C000. So every Kmalloc address starts from here, and everything is just added on top of this. So if I... okay, let's see. So I have something, but is that something actually mapped? What exactly did I get, first of all? Because I did get something as C000. So I think this mapping is just fine. In my EL1 I have 0x something to C00 something. Let's just say C here. And even here it should be FFFF 000 and C something. And it's 0000 C something. And then my malloc gives me 000 C something. I'm trying to convert this address into user space by making it's just converting it back to this, so it would be 000 C something. Now I'm trying to map 000 C. Now this something is not a physical address, this will be the virtual address within my user space. Trying to map virtual within my user space to 000 C something in my kernel, in my physical range, so my user process can access this thing. Okay, that makes sense. And is there any other stuff left? My kernel stack, this address is will be reached from when will I actually use this? If I use some exception, then probably I might use this. Let's get back to this. Maybe we'll have to add an entry for this, because when I get back into some exception level, what table will there be? What is the table? Okay, this was the question that I had yesterday. So when I am inside my user process, I have my own table and I have my entries. And as soon as a interrupt occurs, I am inside the interrupt handler, and in there I am inside EL1, and for EL1 I'll have a separate table. Okay, that table is common among everything, even for every process and um, for every process and every exception level, because I don't change that at all. It's going to be static and it's just one table, so that is fine. So, and I don't update that at all, but I am allocating it with kmalloc, and I'm just going to directly use it here. So that's fine. And we are scheduling it. Looks perfect to me. I don't know. This does not seem to have any issues. I think we have to go one step at a time. So the final thing, ELR is supposed to chain. Let's say 100 and remove this fucking, no, I put heads 100. Okay, let's check what is in this address. It's IIQ entry, so I need to find the return address of that IRQ. And is it this? EL1 PC. ELR should be the return address. And why am I still inside an another IRQ? Okay, what about this address? Okay, I am inside vector EL1 sync entry. It's EL1 sync entry. Wait, EL1 sync entry. It should be EL1 IRQ entry, right? What is my AL1 sync entry? My AL1 sync entry is not yet fully completed. I just simply store ESREL1 and compare the bits and check if it's a syscall or not, and if it's not, I call not a syscall. And what does not a syscall do? It will just do erit. But why am I inside sync entry? What are the reasons we would reach sync entry? If it's a syscall, maybe even for normal exceptions, we will enter sync. So it was not a. It's normal. Okay, whatever. We need to go behind that vector, and we need to figure out which one triggered that. Let's just see. Let's just copy this. And let's just hope our chemo logs is still readable. See, the stack pointers this. Then what the hell am I expecting there? Is it shift H? Shift U, shift I, control U. Okay, it's control U. Okay, I guess we'll go the manual way. I need to go to the first exception. Maybe if we search for that, we would get it. Okay. In that case, let's check behind exception. Okay, is this the first? No, it was not. That's disappointing. I think that's why we need the line number. Now we should be able to figure it out. We need to go to this line number. It's just copy that and here. Okay, this is the last. If we go back, let's see what's in there. What was the last instruction before that? That's my question. Here the SP is 0000. Right. Here the SP seems to be valid, and we have an exception here. And it's an IRQ. for CPU 0. And the ELR is this. Okay. Holy fucking moly. Did I miss that? Oh shit. Okay. Let's just fucking type it. 0 0 5 1 2 3 4 8 1 2 3 0 4 8 0. Okay. Why can't I fucking okay? I still don't have MMU, so I can just put this. And it's came in 420. Okay. At this point we got an IRQ. Maybe it's just timer IRQ, so it does not matter. Once the timer IRQ hits us, we switch back to what do we switch back? I don't know. I'm just keep scrolling, hoping something would pop up. But I guess I have an idea of what's happening. Because I have fixed something in my code, and the SP is getting actually updated. Once I get into the user process, and once a timer interrupt occurs, I'm getting back to EL1, and there I'm trying to access something, and I don't have an probably I don't have page table entries for it. But then it should be a page fault, not an access fault. No. Oh shit. What's going behind? HB. Oh shit show. I think I don't know. How are we gonna figure this out? Well, it always comes back to us, so I guess we can figure it out. Okay, this idea is too slow. Let's just try something else. what we know for sure is that we got an fault at this address, and this address, who accessed this address first? That was my question. And based on the logs, it looks like this. It looks like this. Also, the SP was at some point pointing to 00000. That's just so fucking sad. Right? Then I can also do SP equal to, and not put this. Not head. Probably I'll need the tail. Probably I'll need everything. So for a long time we are just that's just interrupt handler getting stuck. So that doesn't mean anything. Let's just put head equal to 1000. Okay, then I'll put 9,000. I think we'll never reach that code. We need something little more better. Okay, maybe I'll just kill it, and that counts. Okay. No, maybe. Okay, still I fucked up. Okay, then I'll just put jump. No, it's a read only. It's Mac fucking OS. You can't simply write things. It's unmutable. I think now I can do this without getting into buffer limits. But still, it would be so much faster if we can go into the middle. I guess there's some shortcut, but I don't remember that. Wait, it should be somewhere in 13. Okay. Oh, fuck. I just want to find the last stack pointer and what happened there. What changed after, and then we got this fucking SP value. Okay, that's just so fucking annoying. It's a disaster. Let's just leave it as it. We'll think about another way. That's just I'm too slow to scroll, or I need a better way to find where we stopped before we updated the SP. Is there watch command to just watch SP? But that would cause so much noise because the SP is updated quite often. I need something better. What can I use? Hopefully it's still streaming. Sometimes I wonder if it is. What can I do? What can I do? How come SP is getting updated? Maybe SP is just pointing to that. When I get back, I don't even update that part. So the kernel stack is there, but in general, when I get into my interrupt handler, I think this issue is related to me turning off this. I think it should be enabled. So we just tried to debug something that should not have been debugged. We should be debugging something else. Okay, now we got an error. Now let's check the Kernel. Okay, we were here and then we switched into something and then we fucked up and we reached this. Okay, let's just check far. Let's check all the. It's EL0 to EL1. Okay, we were somewhere in this region and then we got an exception. What about our stack pointers? Based on our stack pointer updates, we have a proper stack pointer around this. .1466006. Okay, what happened after that? Bash build /xi xg 8.123.29.5c. Okay, we did. After fixing that, we are getting into the first, and there we try to access the, no, this is first user enter. That's the that means we are still inside the kernel codes. If we are still inside the kernel code, how the fuck did stack pointer automatically change? Because as we can see, the stack pointer is this. Because like 2 instructions before, we have a SP that is here, and then the SP in the next instruction. Okay, for this particular instruction, what it is, I think I must have done something super fucking, yeah, I'm updating SP in this instruction, and the next instruction is, I have a different SP, and the next instruction is the next one, and we are fucked already here. Okay, so we're not simply supposed to update the fucking thing. Okay. What can we do? As you can see, the issue was this: we were updating this pointer, we are updating our value into the SP. That is fine, but then we do some operation with that SP, assuming that it was the previous pointer, which is wrong. And if we go back into our fucking code, the thing is that we are only updating EL0, and we are still inside EL1. How the fuck does accessing EL SP is okay? We have one question at least. Let's just write this down. we are inside EL1 because we are still inside this function. There is this first user enter. It still hasn't switched back into the user process because first user enter is still EL1 because I when I call this I'm only inside. Where am I? Where is it? I'm inside here and I call this macro. That macro is still also running within EL1, and only when I finally call erit I'll be switching to EL0. So I'm still inside EL1. Inside EL1, and I am updating my SPEL0. As we saw, it's a physical register, and SP is the virtual alias, and SP is supposed to point to whichever EL1. So we only updated EL0, but the next instruction, but when the next instruction tried to access ESP, this had the new SPEL0 value. The variables are we enable PL state equal to equal to 1. So what is happening? I am not sure because it seems contradicting the code here. Or am I missing something? Okay, wait, let's check, because as you can see, if the P state is 0, we will choose EL1, or if the P state is 1, we'll always choose whichever PSEL1 value is set to. Maybe we are updating PSEL1 and I'm just reading it fucking wrong. No, we are updating EL0. So maybe I can read what was in EL1 at this point. That would make sense. Okay, let's just read that. I guess first I have to run this. Let's run this. And it never reached that fucking thing. Okay, I have to put the FFF. Sometimes I forget that my kernel is inside a virtual space. This time it should stop. Okay, it stopped. Now let's check things. X and SP. Our current SP is this. This is our current SP. And let's check SP EL0. Is it SPEL0? Yeah. SPEL0 is pointing to 0. Maybe that's why we have zero values at some point. I don't know. Let's check SPEL1. And SPEL1 is pointing to this. And what's the current instruction? The current instruction is move x0 into SP. Okay. I am updating x0 into SP. Then what else? What am I expecting? I'm fucking... No, 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 no. That's valid because that's my fucking code. Maybe this is the fucking wrong thing. Why am I moving x0 into SP first of all? I want the first, because this function is getting the first argument as a pointer to context. And why am I moving that value into SP? And then I'm accessing everything based on that value. I think that is not even needed. I could just use any other register. Yes, I could have just used any fucking register there because it's just a pointer and I need pointer plus arithmetic. So why the fuck did I... there's no requirement that user space is expecting that value to be in that particular location. So for sure, I could just simply change this whole SP into something else. Yes. What can I change it into? I need a register. Okay, maybe that's why, because I need to store all the registers. So somehow, maybe that's why I decided not to touch it. And I just put it into stack. In that case, I have to save the stack and then go back to that stack, something like that. Then where would I save it? Even for saving it, I need some occasion because I need to save all the registers too. I think it's not specifically needed to have everything exactly as it is. Oh, maybe it is needed because we can't be sure that how the user process actually used it. It could have just used anything here. So my conundrum here is that I need a place to wait. This is just for user first enter. This is just one time thing. In other cases, looks even worse. I'm saving things inside stack and I'm moving SP to X0. Okay, the stack still stays the same, and then I move x0 back into SP. So I am restoring things correctly here, at least because I store the stack and then I use it and then I restore it. What is save context does? What does it do? It's just going to decrement it. I think using SP like this is not good. Even this is going to fuck with me someday. Let's just write a comment here. Why we using SP here sounds bad. Fix this. But leave that part. First of all, let's just think about our case. That is the first user enter, and it's just going to happen once. And we have the first argument as the pointer to context, and we move it into SP. Do we have to move it into SP? And this is being only called at first time, so we don't really have anything in other registers. So I could just simply store it inside x11, and I could just simply, and then when I come here I am going to be using x11 as the base. Let's check that. Control, oh shit, Control V, and let's just put what the fuck. How do we insert? I don't know. I think I have to select and replace it. That's not interesting at all. Holy fucking holy. I think I'll just try G first of all. No, it did not work. I think I have to put append, something like that. If I select this and I say shift I, shift A, if I put shift A, it's append. Okay, and I put x11. Okay. And I also save x11, but I guess it's just fine. And My pointer is in x11 and I have to use byte-wise operations to use it. So I also connected this. Okay. x11 plus something will give me this value and I store it here. x11 plus something value will give me this and I'm storing it here. And I do that for everything. And maybe then I don't need this. I guess I remember why I used this, because I was thinking that I might need this when I come back. Because in this context, from this perspective, okay, let's consider from this perspective, if I keep it inside the stack and I just move the stack up below or above, then that particular memory location will always have that entire thing. So it will never be deleted. And when I come back, I can reuse that. I guess that's why I used it. Now, even now, I guess it should be fine because that pointed context value is somewhere. I think nobody is going to delete that. It doesn't have to be inside the. Okay, because I have added that, I might also have to fix this. Is there anything like IRQ will put the context on the stack? No, there's no such thing. I'm just saving the current context in stack. I'm saving the current context in stack because I'm in the current stack. I take this much space and then I save everything there, and then I move the current SP saved SP pointer into x0 and I pass that to IRQ dispatcher. I guess this is correct. And then I can just move the x0 back to SP and I can restore and write. This is correct. What is not correct is that we don't have to do the same thing for when we get into the this is fine. This is fine because when we get into this, the stack pointer should be in a correct position. We don't probably have to update it because we are in EL1. So if we are inside already in EL1, so the stack pointer is pointing to the correct location. So we can just store it and we can use it and we can restore it. This is fine, but when we are first getting into a user process, this is where we should not use the stack pointer, because currently if we use the stack pointer, let's say I'm using the current stack pointer and I move my x0 into that. I'm moving, in a way, I'm moving into my actual, what is this here? Here I have allocated some space, and that space is inside ktop. Okay. And that context, this pointer is going to be used there. Okay, maybe that is also valid because I'm using that location within kernel stack, so I have thought about it. It's just that I don't remember it because here I am allocating kernel stack, and inside the kernel stack I am reducing it to the context size and using that as the pointer, so it is always inside the kernel stack. Maybe the only issue is that I might have to properly use the kernel stack whenever I use it, because I should not start from here, because if I start from here I would override this context. I might have to start from what, ktop minus context size as my top. Okay, what else? Only thing left to figure out is that how am I going to jump into my actual kernel. So I move x0 into SB, so that is a valid location that can be used, so that's fine. And then I use that to calculate all these values. And at some point I am updating my SPEL1. Let's just double check this. We are at that SP move. Okay, let's just move. Currently SP is this. Let's move one step, and we are inside the we are inside somewhere, but currently our SP would have changed. Our SP is this, and our SPEL1 is still pointing to this. That's interesting. What about SPEL0? SPEL0 is still pointing to that. Okay, let's try S1. We are moving X1 into TLB EL1, that's fine. We are taking the next intersection. Now we are moving this into SPL0. Let's see what happens. What exactly are we moving into SPL0? X1. We are moving 0 into. Okay, so that's another issue. So currently we are moving 0 into SPL0. Okay, fuck me. I thought I fixed this yesterday. SPL 0 is pointing to 0. That is not good. That is not good. Where do we set that? I guess it should be inside the build context, and we are passing user stack, and user stack is supposed to be printed here, and it has a proper value at till this point. So if we come here and SPL 0 is set to that properly, so that is not the issue. The issue probably is that we are not handling the operation. Where exactly is that? My vector.s, and when I save something, maybe the issue is that I'm mistaking the orders. I guess that's the issue. This is the thing. Let's just put 200. And if we do that, we could see things here. So the values are here. It's just that we don't access them correctly. But why? It is here. It starts from E0 and it's increasing. The values are increasing. And we are also accessing it in terms of plus, SP plus, not SP minus. Because we try to access TLB EL1 value, which should be the last element in the structure, from SP into 34 into 8. Maybe that's the issue. We just put 34 here. And let's just change it back to what it was before. It's 32, and 33, and 34. What was in here before? What? We have added one new thing, and that will be in 31. And the second one will be in 32. Third one will be in 35, 31, 32, 33, and 34. Actually, it should be in 34 because that's the final thing. The final thing should be in 34 and 33 and 32, 31. So we have 31 here, 31 into 8. And SPR. And then we have the ELR. And then we have ESP and 34 and 34. I don't know. Should break first of all. XSP plus 272 we have we have 272, which is in when we try to access this, we are getting 80. We are getting 80F000, which is what? What is 80F00? Is it our TLB value? Let's just double check that. Maybe it is, because I remember moving it somewhere. I think it's here. Maybe it's in that hatch. Yeah, user table 1 is in FF. Okay, so that is correct. Let's try 64. Yesterday we did this. And the next one is set to 0. Why? Okay. After that it's SPSREL1 and then ELR1 and then I have SPEL1. Okay. That's the issue. Okay. Then where's my vectors? Here I get the values. This is the first value I'm getting. Maybe that's the issue, because I'm where's the fucking thing? I just fucked up the order. Initially it was SPREL1 and then ELR1 and SPL, and I had the values in reverse order because SPL1 is supposed to be taken in reverse order because I have placed it in reverse order, because previously SPREL1 was the last value and it was here, and my SPREL1 was 34 here. I think previously it was just correct because I manually changed the order here because I have SPR as the final one. Maybe let's just stick to proper ordering. If we are reading it from top to bottom, this should be 31st, this should be 32nd, and this should be 33rd, and this should be 34th. and let's name things exactly as it is here. We have 34th value and 33rd value should be this, and 32nd value should be this, and 31st value should be this. It should be 33rd, it should be, and this always stays 32 because that was in the center. Probably that's why the switch somehow worked even without having the other values properly set. So now we have TLBR as the final. Before that we have SP, and then we have ELR1, and then we have SPL0. Okay, now let's try this. And we have to read it from 34th, 33rd, 32, 31st, and the entire sizes of 34. Okay, let's try it again. Stop and here, run it, and let's just check the SP is this. Let's just move one pointer and let's check. 272 we have this, and then 264 we have 0, and 256 we have 890. Okay, let's just check that. We just have to put x1. X1 is correct because it's 80FFF, so TRB value is updated properly. Now let's see SPEL1. SPEL1 is now pointing to the correct one. Okay, now let's check ELR-EL1, and it sees user process, that's also correct. And SPREL1 is, I guess, just 0, and I guess we can just simply move through all these zeros, and we get into SP user process, and we get an fault at address 800090. Why? Our table is supposed to have this. Where's our table? We are adding the entry. Entry would be kernel to user space, and let's just maybe print entry then, so we'll get an idea of if the entry is mapped properly. Are any other print messages? Okay. ID is D and entry is L. ID is ID, entry is entry. UN 6040. Okay, let's hope that it will work. Stop. Okay, first of all, let's just run it once fully without stopping. Just put bash build. Okay, we kill it. And if we go to user stack and where is ID1, ID1 and entry is this. If we put it here, it is correct. And what was my error? And it was an exception of far. Okay, the actual exception happened in this address. This was just probably GDB was not able to sync it, because after we update the maybe we have to fix catch. I don't know, probably that would have done by it. Okay, whatever, but if we just let it run, we get a different error, which is 47. What is 47? Is it L1? Yeah, trying to read from this address and we got an error. Why did we try to read from that address? Okay, let's check this first of all. Okay. My stack pointer was C600, and the moment and the stack pointer will be reduced. I mean, like the stack grows below, but my page table entry is for 600 plus 4 KB. I guess I need 600 minus 4 KB as my page table. That's sad. Stack grows in the opposite direction, so I need entries below it. How do I do that? Okay, so issue was that, guys. Okay, so now we have a new error to write down, because let's just fucking write everything, whatever we get. That was happening correct. It was just my own fucking mistake, the previous one. Now we have a stack pointer that is 0x C123 6123. This is our stack pointer, and we have a page table entry for 0xc 0006000 plus 4kb, but the stack grows below cx C000600. That is, let's just take our own example. So we get the files. Okay, fuck it. Okay. Okay, I guess we'll think about it next time. It's been a long time and there's just too much debugging. But at least today we were able to at least jump into right now. I guess we have only fixed our MMU, our vector table a little bit better. There is still this and the structure of our context, and when we added a new thing it broke everything, so we had to restructure this. Other than that, we did not do anything, I believe. What is this change? Yeah, we just added those two entries. We did not change anything else. And we also learned about the also we learned about the SP aliasing for different exception levels. I guess next week we'll have to fix this part. Thus, we need to add entries below the page table. Nothing much. Okay. Thank you guys. Bye bye.